Hi everybody, and welcome to the first multi-tenancy working group for Kubernetes meeting of 2020. Today Adita is going to be going over Kubeflow and the multi-tenancy model from Kubeflow, and then as time permits, Jim is going to go over some updates from our benchmarking work. So Adita, take it away.
Hey everyone, I'm Adita. I work at Cisco and I work on Kubeflow. I'm just going to go over quickly on what Kubeflow is and then the multi-tenancy model with Kubeflow, and then kind of uh, see the gaps between the current multi-tenancy model with Kubernetes upstream, and then what is needed for Kubeflow, and then kind of hopefully have a discussion at the end, kind of yeah. So firstly, introducing what Kubeflow is. Kubeflow is an ML toolkit for Kubernetes. The goal is to provide a platform for portable scale machine learning. So most of cloud natives um, problem space is similar to what you solve for an ML system, ML platform as a service. So suppose you have a team of data scientists in your company and you want to provide them with a platform to use the or get the maximum out of the infrastructure at your company. The way you'd go for with app development is to go for Kubernetes, and for data science, you'd go for Kubeflow. And so what are the advantages that we have with Kubeflow is that you can kind of go from local to your cloud environment without any changes in your workflow. So you'd have the same reproducible workflow from your local machine to the cloud, and then and across environment as well. So if you're going from development of a model, when you're experimenting with different model types with different accuracies and different frameworks, and then you can, once you finalize the particular workflow, you can go from your development to your production seamlessly. And currently, there's a lot of ad hoc pipelines and stuff used at companies, and Kubeflow aims to provide a standardized way of deploying models and developing models for that. And another thing Kubernetes helps with is scale. When you have a set of GPUs or a cluster of GPUs and you want to efficiently maximize the usage of those resources within the cluster, you can use Kubernetes and make use of the resource scheduling with Kubernetes for that. And as to why you need cloud native for machine learning, similarly, how you have polyglot app developers, and you don't want to restrict people to kind of using a certain stack or a certain set of languages and toolkits. Similarly, for data scientists, you don't want to restrict people to using a TensorFlow or PyTorch or anything of that sort. You want to give data scientists the freedom to pick and choose whatever they want to do for the particular problem at hand. And Kubernetes kind of helps with that. And then another example is the OpenAI experiment. Like, they frequently scale to massively huge clusters, and this is kind of proved as a golden path for other people to kind of follow and implement a similar platform as a service on Kubernetes. And coming to why multi-tenancy is needed for Kubeflow, initially Kubeflow until the right now Kubeflow is at a 0.7 release. Initially, till the 0.3 release, we had went for a single tenant model wherein each data scientist gets their own Kubeflow cluster. And when we started adding components like Istio onto the cluster, we kind of it didn't like, we didn't want to have a lot of operational complexity. So we went for a model in which you have a single cluster with uh, the control plane installed on it, and then you have tenants sharing that control plane from within that cluster. And you can also have restricted resource sharing. You can enforce resource quotas on single users, and then kind of have a cap on users' GPU usage, and conversely, you can put a cap on the billing and resource usage from that. And then another reason was to kind of have separating user experiments and workflows. So Um, in single cluster, in a single cluster, typically you'd have a lot people wanting to share experiments and sharing their namespace so that you can like deploy to production or reuse most of the workflows that people are using. So the namespace model was kind of easier to kind of add people to namespaces and then share their workflows and stuff. And regarding the architecture for Kubeflow multi-tenancy, uh, so uh, Kubeflow kind of follows a self-serve model wherein the Istio ingress gateway access the entry point for users. A data scientist is not expected to know Kubernetes or kubectl commands, so the admins access the kubectl entry points, and then the data scientists use the Istio ingress gateway and directly connect to the Kubeflow UI through that. At the Istio ingress gateway, you have an envoy filter that kind of redirects to whatever authentication provider the vendor has. We use DEX for on-prem and non-vendor distributions, and Google uses IAP and a service account based authentication. And then AWS uses Cognito and their IAM based authentication. So we have different workflows for different vendors. And then how it actually handles this is once a new user comes in and you get a new token from a user, you have a profile CRD, which is a custom resource that creates a new namespace for that particular new user, and role bindings to access the Kubeflow um, services, and then create resources within that namespace, and an Istio service role and service role binding for accessing the Kubeflow services, which would be coming under the Istio ingress gateway. So the way Kubeflow works is that you have multiple services within the Istio ingress gateway, and then the Istio you have certain services like the databases and stuff would be locked on for the data scientists, and you'd want to have different models for different user personas per se. And then it follows a soft multi-tenancy model, which is from Jesse Fraz's document. So it's like you assume that all users are kind of trusted, and you don't have hard differentiations, or you assume that most people are within the company or within the team or something like that. And then
Can I
yeah.
just ask a quick question? Can you go back to the prior slide just for
Yeah.
one? Sorry, this is Adrian speaking.
Oh, yeah.
The Kubeflow API request, so this is like from kubectl, right? Or is this?
This is from, you directly access the Istio ingress endpoint. That would be a URL.
Okay, so what kind of API request is this going to be? Is this like a model serving request or a model training request or both?
So it's a UI, so you'd directly access it through the browser, and then you'd have a login page wherein you can like enter your new namespace or user ID that you want, and then you'd have the profiles controller which would take over from that and then create the associated cluster resources for you.
Oh, I see that. I see. Okay, thank you.
So, Aditya, I think it's worth adding a little bit more detail on this, okay? And let me share a few points, and maybe they'll help a bit more. The first thing is that what you're calling the Kubeflow API gateway here is essentially the Istio ingress gateway with routes for the Kubeflow app, for the Kubeflow dashboard, right? So the green square is essentially the Istio ingress gateway programmed to forward to Kubeflow dashboard app.
Yeah, you have the Istio virtual services for each and every microservice associated with Kubeflow. You have the Kubeflow central dashboard, and then you have Jupyter Web App and for creating notebooks and stuff like that. So you also have the pipeline dashboard and stuff like that. So you have different microservices each with its own Istio virtual service, and the user or the data scientist hits the Istio ingress gateway, and then once they are authenticated and you have an associated profile created for them, you can then using the Istio service role you sort of get access to the different virtual services within the Kubeflow namespace.
Right. So a couple of consequences of that are, number one, Kubeflow appears to be relatively closely coupled with Istio, meaning that
Yeah.
although in theory you could have deployed Kubeflow without Istio, it is for some reason very relatively tightly coupled with Istio currently.
Yeah. So the central dashboard kind of has even like for accessing the different services within the central dashboard, you'd need to have Istio virtual services. We previously used Ambassador API Gateway for that, but we wanted authentication and stuff, so we kind of shifted to Istio from 0.6.
Right.
Yeah.
Right. But the coupling with the authentication server is loose. That can be anything. That can be
Yeah.
direct.
So that is like that is a drop-in thing wherein you create a custom envoy filter that redirects to your authentication connector. So if you have the envoy filter directing towards whatever provider that you want to give it.
Right. Can you also move to the next slide?
Yep.
So here, when we say profiles, this is essentially a set of namespace config, right?
Yeah.
This is a namespace with X number of Kate's role bindings and Y number of Istio service role bindings. Is there anything in the profile which is kind of like any Istio based app would need this sort of thing? This is really not directly Kubeflow specific. It's a reference for Kubeflow, but the other Istio based app in a namespace would kind of be doing similar stuff.
Yeah. And there's two things here. One is for the Istio related services, and then for the Kubernetes related services, you have the role and the role bindings. So most of the Kubeflow workflows are dependent on another set of operators. Those are like, for example, the TF operator creates TF jobs, which is the TensorFlow operator. So if a user or a data scientist wants to train or serve using KF serving, which is again another custom resource. So you need role and role bindings to tie into the Kubernetes resources and create those resources. So in order to create that, you need the role and role bindings as well.
Yeah. Let's keep going. We'll have some more points later.
Yeah.
So one quick question there is a profile limited to a single namespace, or can it point to multiple namespaces?
Right now, a profile is associated with one single namespace, and you can like have one user having like using multiple profiles.
Okay, but they would switch between profiles to operate, or it's simultaneous?
You'd have the token associated with the user, so it would automatically forward requests according to that token.
And what's the
OADC token?
And under what circumstances would a user do something like that? Why would one user want multiple profiles?
Oh, suppose a user wants to share a namespace. Suppose you have a single user, a data scientist using their own namespace, and suppose you have a team namespace which is shared between a bunch of users. So in that case, you'd want to have a separate profile for the individual namespace and then another namespace which is shared between a team.
So what goes inside a namespace? I guess all the like the model itself.
Oh yeah. So you deploy a set of the control plane is shared with the namespace. So the control plane consists of a bunch of services and CRDs, and you can sort of have separate like the volumes and volume claims are restricted to a single namespace, and resource quota, if it exists, that would be restricted to the namespace, and anything that is user specific would be restricted to that namespace, and anything that is global that is at the Kubeflow level would be in the Kubeflow namespace, and it would be shared across the cluster.
I guess I'm just saying, like in the sort of Kubeflow problem domain, it's mainly the main stuff is going to be the volumes, right? That's where the data is.
Yeah.
Okay, thanks.
Yeah. Sure. This is the workflow that I described. Like you have the API gateway, which is really the Istio ingress gateway. And then you have a self-serve model wherein a user logs in to the endpoint, and then they are redirected to the authentication connector, and then they fetch their authentication, like identification credentials from whatever identity provider that the connector uses, and then you sort of have that token attached as a header for each and every request that the user sends through the ingress gateway.
So the connection to the OIDC gateway is through the Kubeflow UI, not through the Istio gateway. Is that right? Istio itself does not have an OIDC.
Yeah, that is why you use the envoy filter to kind of bundle in the token onto the header for each and every request.
Okay.
And that kind of is forwarded through the system.
Istio does have an OIDC connection or validation plugin, but it's not that feature rich.
Oh yeah, we did evaluate that initially, but then at that time, I guess it wasn't, when we were using it, it was around Istio 1.0 or 1.1, I guess. So it wasn't that mature for the needs. So we went with an envoy filter at that time.
Mm-hmm.
So is the purpose of the Istio filter only to secure the dashboard, or is it also providing? And so, what if the dashboard is, the Kubeflow dashboard is not used? Do you still need the Istio filter and the authorization at that level? Because in your diagram, you also show kubectl access.
Yeah. So in that case, so the kubectl access is mainly for the Kubernetes admins, and the API or the UI access is for data scientists. So we kind of separate that into two personas, and we have different modes of access for each persona, I guess.
With Kubeflow, I believe you have said that the UI is the only way of interacting with it. There is no Kubeflow CLI. Is that right?
Oh, no, we don't have a CLI for accessing the. Yeah, there is no CLI. You just have the UI for accessing the different services. But you can use the kubectl access for creating custom resources and stuff like that. But like you can do everything that you do with the UI with kubectl, but it's more user friendly for data scientists to not use kubectl.
Is there also, I seem to recall hearing of a kfctl?
Oh yeah, that is for managing the life cycle of Kubeflow clusters, like installing Kubeflow and deleting Kubeflow. It's more like it's more like kubeadm, I guess.
Does that also come through Istio?
No, it installs Istio as well. Like it installs all the control plane components for Kubeflow.
Okay.
Yeah, so that was that. And then regarding future work and roadmap, so currently you have a restricted set of things that Profile CR installs with the initial workflow. So the future roadmap is to kind of have a plugin model which can inject any set of resources. For example, right now each user gets a blank namespace with nothing on it. So if a user wants to create a volume, they'd still need to know some sort of Kubernetes to actually create a persistent volume depending on the environment they're in. For example, if you're in on-prem, then you need to have some sort of for example, if you're in AWS, you'd use EBS volumes or something like that. And then it depends on the cloud environment that you're in. And then, so if you have a plugin model, then you can sort of have a model wherein a user, when they log in and a profile is created, you automatically get a standard volume that you can use, and you have a automatic injection of resources. Like, for example, you'd need to authenticate to different cloud services or something like that. In that case, you can automatically inject those credentials inside the namespace so that you can use those credentials and authenticate and use those cloud services. And then currently for the on-prem model, since we're using Dex, we need to modify the API server flags in order to enable like Dex. And this needs K8's master node access. So this is not possible in AWS. AWS, they initially wanted to go with the upstream implementation, but they had to choose a vendor specific one because of this. So it like we have different solutions for different vendors right now. So it would be easier if we can avoid modifying the API server flags for that particular thing. And then another thing is to have a CRD similar to the profiles. So we went with the profile CRD because at that time the multi-tenancy working group, they the there was no notion of a tenant CRD at that time. So we had to like create, the community had to create their own. So if there is something that we can adopt from the multi-tenancy working group, that would be super simple for the community to kind of adopt that and use that, reuse that, and that would also reduce the maintenance overhead from the community perspective. Yeah, so coming to the missing pieces.
One more thing on the prior
yeah.
slide, Aditya.
Yeah.
Is the current version of that CRD in a separate repo from the actual Kubeflow stuff? Because it's sort of independent of Kubeflow, right? The tenant CRs.
Yeah, it is a separate, it's not in a separate repo, but it is a separate CRD that we house all the CRDs. Like we have the notebook CRD and the OpenMPI CRD and the profile CRD as well. So this is the profile CRD.
So I think we should talk about how we can leverage the tenant CRD that the working group is doing. And also, we have sort of been a little bit ambiguous, but the point about namespace automation is that we've been leaning to leverage existing projects for namespace automation. So a combination of the tenant CRD plus namespace automation would do the job for Kubeflow as well.
So what do you mean by namespace automation?
I'm sorry, could you repeat that?
Sorry, Sanjeev, what did you mean by namespace automation?
So things like that Red Hat project that we had
the label, the namespace configurator.
The namespace pre-configurator, and optionally with HNC as well, if there's having a hierarchical namespace here. So all of those are things I think that they can be an opportunity for reuse.
Yeah, also policy engines that support generation of configs. That would be another way to
yeah, that would be useful for kind of giving access to giving access and restricting to Kubernetes resources from a user point of view, I guess.
Yeah, I feel like to do something like this, you could have a combination of HNC, which allows self-service namespace creation, because then you could you could put Kubeflow. I heard a couple of people mention this at KubeCon in San Diego, that they have a cluster specifically for Kubeflow because it doesn't play as well with others. It needs cluster level privileges and stuff like that.
Yeah.
With HNC, I don't know if you've looked at that, Aditya, but we could talk about it afterwards if you like.
Yeah, sure.
You can have you can create a root namespace and then say, well, Kubeflow is allowed to create sub namespaces just within that, and then various policies get copied directly into that from, like, inherited from the parent, such as RBAC privileges and stuff like that. But if you want to put new stuff into each newly created namespace, you could either use the namespace configurator, which could say, like, oh, for every new first level sub namespace that's created, copy these things in, I don't know how you would customize that for every, like, one per tenant, but I also don't know if you necessarily need
Oh,
to.
we don't need to customize that for each tenant. A standard drop-in would work, I guess.
A standard drop-in. Okay, yeah. So
Yeah.
NC, I think it's called NCO now, namespace configuration operator.
Okay.
NCO from Red Hat should be able to do that. So if you maybe you can have a look and we can see how those two. Also want some kind of sandboxing for
sure.
gvisor Catacomb is one of those.
You'd need gvisor or Firecracker or something like that to kind of separate out each tenant, I guess.
Yep,
and,
exactly.
I mean, additionally, storage is going to be tricky there as well, considering PVCs are namespace scope, but the persistent volume itself is mounted at the cluster level, so you need some form of isolation.
I know Jim's looking at hard multi-tenancy. I think that at the control plane, virtual clusters is about the only thing I know of right now. I mean, it is possible. Obviously, if you configure things very, 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 very carefully, and people don't need CRDs, it is possible to do it all in one cluster without virtual cluster. But of course, the whole point of that is that it's very delicate, and so with virtual clusters, your only kind of surefire way to do that.
But I don't even think virtual cluster fully supports the storage aspect, does it? At least that's what I heard.
Faye?
Storage?
Correct.
The PV? You mean?
Yeah.
That is a little bit tricky.
Yeah, that is kind of like a very future part, I guess, because the other things are more current.
I think the networking aspect, if you're speaking on behalf of cloud vendor, networking, isolation part, they have a little bit good solution, but for storage, it is very tricky because it's kind of who want to create that piece of persistent volume, who owns it.
Yeah, and so one of the kind of workarounds I've kind of looked, I've never actually fully tested this from a security perspective to break it, but you could potentially do a new storage class for each tenant, because then the persistent volume can only be mounted by somebody with access to the storage class, and you can do normal RBAC for users for storage classes. So you can at least limit a tenant creating a PVC for an unclaimed PV of somebody else.
Oh, cool. Yeah, that is interesting.
So Ryan, just to clarify that a little bit, so is it possible to mount a PV across namespaces? My understanding was you could only do that.
Well, so the PV is cluster. The PV is at the cluster level, right? And then the PVC is namespace close. Okay. So there's technically a race condition. If you, if the PVC gets unmounted or deleted during a rolling reboot or something, the PV sits unclaimed potentially.
I see. So unclaimed. Having unclaimed PVs in a multi-tenant model would be a no-no then.
Yeah, you have potential issues, but with that kind of storage class workaround, you can kind of make that prevented a little bit, because then the PVC of another tenant won't have access to mount a PV of a storage class they don't actually have access to.
Okay.
That makes sense.
Yeah, it does. That could be an interesting solution. Okay, so one other question, Aditya, on the type of tenancy supported today. So is there any, within the profile, does it also create things like network policies, resource quotas?
You can drop in a resource quota for now, but we don't have any network policy drop-ins at the from the profiles perspective.
Is there any support for doing anything with service mesh with Istio in terms of network isolation across tenants?
Let me think
network
about
isolation.
You mean like having network policies with, as a, oh, sorry.
This is Kunming from Kubeflow team. So now we establish network isolations through istio policies. So
okay.
User can choose to turn on the features, and all the networks, the network requests are only all the services. First of all the services are bounded with istio sidecars. So talking to the services through istio sidecars only, and secondly, by default, only the traffic from within the same namespace plus from the ingress is allowed. So cross namespace traffic through ingress, through istio sidecar is not allowed. That's how, if you want to achieve like a relatively strong network isolation.
Plus everything's encrypted through, or can be at least, through MTLS, right?
Sorry, what is the question?
Plus in Istio, everything is encrypted via MTLS, right?
It's
not exactly. I mean, you have to turn it on.
Yeah, I don't think people turn it on.
Yeah, many people don't because it adds a lot more complexity. I unfortunately have turned it on, and it adds a lot more complexity.
I didn't realize that. I've never tried. What is
the default with Istio is turned on with TLS, but you can put it, but they do set a policy to permissive, so you can still make calls to services that don't have it enabled.
Mm-hmm.
So was there a reason for not using network policies and preferring Istio policies?
The reason is, let's see, how are we gonna patch a network policy when user publish their new services on their own namespace? Like for example, Kubeflow users might publish new services, like they might like serve their new models,
okay,
on like namespace, and want other services to call it, but through the ingress. Right? They might want to expose new services like new notebooks and expose it as service, but like we cannot predict like what will they do, or like it's very hard to like customize, like to patch the network policies following users like practice. So we decided, okay, we're just gonna set up a global rule, very very simple. It's like a namespace as a boundary, like a cross namespace is allowed or disallowed. That's it. Only the request from the ingress is allowed, but the request through ingress, they have been checked against the Istio RBAC rules, right? Which again is controlled by the profile controllers. So we have some kind of control. We make sure that all the traffic through ingress is verified or authenticated. All the traffic within namespace is blindly allowed. So a basic model to simplify the user experience.
Okay.
This goes back to what we were saying earlier, that there seems to be a coupling with Istio, which in theory need not have been the case, but
right.
If the Kubeflow working group is going to almost mandate that Kubeflow must be used only with Istio, are they going to do that, or is Kubeflow?
Yeah, from 0.6 it is compulsory to use with Istio.
Right. So I guess there's some pros and cons to that, but okay.
Yeah.
Yeah, so just thinking more from the multi-tenancy perspective, right? So there are network policies obviously do layer 4 isolation, so there's some value there. So one option could be to have a default network policy for each namespace, but then I understand that it would be easier to automate the Istio policies. So maybe then for each application or each service a data scientist needs, you could still have then a Istio policy to manage the routes and what that can communicate with.
And coming back to our multi-tenancy work here, so there's several areas of sort of overlap and reuse here, and we should probably go over those in a follow-up call. But that also suggests to us that we need to allow for Istio-based network isolation, which has been at the back of our minds, but we haven't explicitly covered it yet.
Right, and I think one of the concerns with that though is it's at layer 7, right? And we probably need to understand that a little bit more and see, is that secure enough for, and at what level?
Yeah. Another point here is that Aditya and the Kubeflow team is that if almost all the time a Kubeflow cluster is only used for Kubeflow, then okay, you can define your own multi-tenancy model, although it would still benefit having reuse. But in general, if a multi-tenant cluster needs multi-tenancy both because of Kubeflow and non-Kubeflow reasons, then you might as well have a common multi-tenancy model, which is what this working group.
Yeah, right now, the suggested like usage policy is to kind of have a exclusive cluster for Kubeflow because of the restrictions that because of this unique way in which we deploy it and kind of configure services within Kubeflow. But it would be ideal to have it kind of play well with other applications as well, I guess.
Yeah, I think it would help regardless of whether Kubeflows are dedicated clusters or shared with non-Kubeflows. I think we should have commonality. So I think let's follow up in subsequent calls.
Yep.
Or maybe we should take this offline. I think maybe.
Yeah, no, we should.
We can speak on the Slack thing.
Yeah.
Yeah, that's pretty much what I had. So if you have any other questions or something, we can move on to the next topic.
Great, thank you for that presentation. Yeah, I think we will hand it over to Jim since we only have 20 minutes left. And if people have additional follow-up questions for Aditya, he'll be in the Slack channel, or you can hit up the mailing list, whatever works. And we can always have you back for a follow-up too if there's a lot of questions. So thank you so much.
Yep, thank you for your time.
All right, so what we wanted to cover in this next section was really just a quick update on multi-tenancy benchmarks, and in fact some of the topics we touched on are very relevant to the discussion here. So just for those of you who might not be familiar with the benchmarking effort and what the goals and purpose are, and there are some links in this document I shared. The goal here was really to focus on the what end results we want to achieve from multi-tenancy and provide a way for users to validate that in their cluster. And that's what we wanted to define as a set of benchmarks. Of course, as soon as you start thinking of things from that perspective, it became apparent there's several different layers or levels of multi-tenancy. So one way of categorizing is, of course, hard and soft multi-tenancy. But the approach we wanted to take was go a little bit more granular than that, right? So I have some links here to what's already also in the GitHub repo in terms of the definitions that we're using, the benchmark types we defined, and really it's just two types of checks, behavioral as well as configuration, and then categories that we define. And there's about 7 or 8 different categories that we listed, and that's shown in the table below. We'll go through it too. So the goal was to try and define, the first level. So that's profile level 1, 2, and 3, and just very briefly, the way these are defined, the details are in these links. But the way they are defined is profile level 1 was using standard Kubernetes constructs and even allowing kubectl type of access so that if necessary, an admin could manually set up a level of multi-tenancy. So this would be, you could think of it as soft multi-tenancy, but we're still requiring, best practices, for example, things you would find in a pod security policy. And we're not mandating that you use pod security policies or anything like that, but that you would still secure, your configurations, for example, to not allow root user access within a container, to not allow shared resources like host resources, things like that.
Sorry, how do you do this without PSPs? Like with
so there are, Yeah, so you can set a security context within the pod itself or within the controller or for each container. So that's, you would configure it in that for each pod or each workload, or use a policy engine like OPA or Kubernetes to automate that.
Okay, yeah.
So I think what we wanted to focus on from from the work in progress perspective was agree to what would constitute a good set of checks for profile level 1. And once we have the definitions, we have a prototype of automating some of these. So using the end-to-end validation tool, what we've shown is it's possible to automate both configuration as well as behavioral checks. So then we can go ahead and implement a set of validation tests for profile level 1. And I think if you look at the overall table, what's interesting here is, so the categories are listed, of course, in the first column. So a lot of focus in profile level 1 is isolating the control plane, making sure each namespace has the proper isolation. So not allowing a single tenant to, for example, just arbitrarily increase their resource quotas or access, of course, other tenant resources, having some level of network security. And this kind of ties back to the prior discussion of, should we mandate, should it be a configuration check with network policies, or are Istio policies good enough for profile level 1, right? And the approach we've taken so far is to say, we're not going to require a particular implementation, but we'll just do more of a runtime check to see if from namespace A, whether you can reach out to namespace B, assuming these are across 2 different tenants. Also on the host isolation, there's about 5 different checks defined to make sure that we're not using host resources, which obviously that could lead to some security uh, concerns, and especially if other uh, security best practices are missed. So, for example, not using host networking, not using the host storage, things to that nature, bind mounts, which would be the host path type of volumes. And then for fairness, right now we have two checks defined. One is both have to do with resource quotas. One's at the object level to make sure that one tenant is not abusing the API server, and then the other would be at the resource level. And others, just kind of thinking of it from this table structure. So level 1 would focus on, again, manual configuration, no namespace level automation, like since you put it required, but something that could be also set up just using kubectl and following the best practices. It would be tedious and difficult to manage, but could be done. Level 2 is where we're requiring self-service namespaces. So a tenant should be able to create additional namespaces and should be able to do other self-service operations. The most common being, creating users for that subtenant or for the tenant, and also allowing, things like network policies, etc. Like was mentioned for Kubeflow, being able to create ingress or egress rules for user level services would be allowed in level 2. And level 3 is where we're thinking of I guess that's the hard multi-tenancy, or moving towards that, where you would use things like virtual cluster, etc. Right? And that's where I think some open questions are related to the networking and storage discussion we just had. Even for storage, we need to decide what would constitute, being sufficient for level 1. For example, as to Ryan's suggestion, should we require that each tenant have their own storage controllers, or as long as there's no unclaimed PVs, however that's implemented, is that what we should check for and audit for?
Sorry, can I just ask a quick question about the self-service ops?
Yeah.
You have create role bindings there. That's you're pretty much always allowed to create a role binding to something you can already do yourself, correct? I think if you have the explicit permission. Is that
within the
right?
namespace? Yes.
Within a namespace, okay. And create network policy. Why is that one of the required ones there?
So for example, if just what was mentioned in the Kubeflow discussion, a data scientist has a new application, or just anytime you run a new application in a namespace, you want to expose a route to that, or have a port, or allow that application to talk to other services. So either ingress or egress, you would want to do this per app.
I could also imagine though that okay, I guess so. I suppose that makes sense. I guess I'm wondering why we're calling that one out. Like, it doesn't say here, like, create deployments or services or stuff like that.
Right, I think those were just more or less assumed.
Yeah, I mean, create namespaces is interesting because it is usually a cluster level privileged operation, and so allowing that in some contexts is quite interesting. But yeah, sorry, I wasn't suggesting that you add it there, but I would guess I was thinking more that anything that you can already do in a namespace is already self-serve.
Right.
So I would just kind of expect that. I would expect like 2, 4, and 5 here to not be needed. We don't need to say them explicitly. They're kind of all subsumed into one, which is once I can create a namespace, I can use it in a sane way.
Right. So assuming that the namespace creator role, or whatever role allowed you to create your namespace, lets you do that, and not violate any multi-tenancy configuration.
Mm-hmm. Yeah, that's right.
Right. So for example, creating a network policy and referencing some other tenant's namespace could be interesting, right? I mean, it would, of course, you'd have to know something about that other namespace, but could you then reach other services within the cluster?
Mm-hmm.
Same thing with role bindings. If a cluster is misconfigured where you have certain overprivileged roles exposed, even at the cluster level, you could create a role binding to that in a namespace, and then you could potentially delete other multi-tenancy configuration in that namespace, which gives you greater privileges. So I think there is value in explicitly checking for these things and making sure that, again, you're not violating some multi-tenancy constraint, which we checked for in level 1.
Okay. Yeah, that sounds good. Thanks.
Yeah, I have a question. So this is Faye. Can you go to the host section? Host
Isolation, yeah.
Yeah. So I think the Binamount node port service, use of IPC PID, that's reasonable. Only the number 3, use of the host networking and the parts. I'm not sure. So if you disallow the use of host networking, it may be possible that some Kubernetes features may not work, like default health check kind of thing. So it depends on the use case.
Right.
So, yeah, some people may insist they want to make sure they pass the conformance test. so even you do this hard multi-tenancy, they want to make sure some common Kubernetes features still work. In that regards, sometimes we probably have to compromise with some solution that need to access host networking, but in a very carefully way. This is some requirements that I have been facing from our customers.
Yeah, that's an interesting one. So yeah, it would be good to maybe discuss more offline and understand what exactly the scenarios.
Yeah, especially typically people use VPC. So once they use VPC, they are isolating naturally with the host.
Right.
But they do have requirements. Sometimes they want to penetrate the PVC in a very dedicated way. So some features still work.
Okay.
I just give you a heads up. So if
right. No, thank you, and I'll follow up with you on that to understand that use case a little bit more, and then yeah, we need to decide whether we make that part or make that like a recommendation and not something that we validate for. And
yeah, exactly.
level one.
Maybe I would say it's rather optional, but because doing this actually makes some Kubernetes function not working.
Okay. All right. So really the goals here, as I said, and feel free to comment on, so this table, I kind of put it in a different form here. If you go to the GitHub repo, there's just a list of, and I can just quickly pull that up and you can take a look. So everything that's in this document is also in GitHub. So you can either, create PRs or issues or questions, or you can just comment on any of these. But really, yeah, one of our goals is to try and get agreement on profile level 1, and then we can start automating the tests and we can see what the end-to-end validation looks like there. Other questions, so I think it would be helpful to do a deeper and maybe have some offline conversations on the networking as well as on the storage. So both of those. So networking, the open question is, should we require network policies? And it's interesting that network policies are very powerful, but a lot of users don't seem to be using them. And so I'm on the fence about saying, yeah, should we make a strong case for it, or should we say, well, you can use different types of network isolation, and we don't require, but then, yeah, how do we check or validate layer 4 versus layer 7 concerns? Storage isolation, I think we already discussed this a little bit, but there's some interesting questions there too. And we need to come up with the right solution, which constitutes the first level of multi-tenancy. And then, I think talking about data plane isolation, so sandboxing, and I think there was a question, Tasha, you had mentioned also at KubeCon, somebody was asking about this, where that would fit. So I think it's absolutely necessary at one of the levels. We need to decide at what level. And the other interesting question there is, how do we verify that, right? Is there a way to test that sandboxing is actually working? And, I think we'd have to talk to somebody who understands sandboxing a lot better than I do to be able to come up with the right check or test for that.
The most, as I understand it, the most you could do is just verify that the runtime class has been set appropriately. I think that's usually how you turn on sandboxing. Because other than that, you would need an unpatched exploit.
Right.
Which are, at least for me, not that easy to come by.
Yep. So those were some of the open questions that I had, and certainly, if there's any other comments, questions, happy to. We have 5 more minutes left, so we could either do a little bit right now, but maybe then we set up offline discussions on these topics. If someone's interested, again, and please do review the definitions and of the benchmarks themselves, and if there's any suggestions, etc., we could just collaborate on those on GitHub. And then for the automation tests, if folks are interested in contributing and writing those automation tests, that would be the next set of things we start looking at. And there are some examples there already, so there's a starting point, and it's fairly easy using the E2E test tool and kubectl type commands to do most of these tests. Any other thoughts, questions, feedback? Is this going in the right direction? And does everybody, just as a checkpoint, does everybody see the value in getting to this level of validation and tests?
I think so. This seems like good progress to me.
Yeah, I think this is awesome work, Jim. Thank you so much for leading this. This is looking really good.
Thank you.
Cool. Well, thank you for a great presentation. As Jim mentioned, if anyone has further questions, Jim, we can schedule Jim for another dive as the work progresses. And also we have Slack, we have the mailing list, so don't be shy. Well, thanks everybody. Good first meeting for the year for sure. I think we're going to get some good stuff done in 2020, and have a good Tuesday.
All right. Bye, everyone.